Uh, Good morning once again, my student of accounting. I'm happy to meet you this for the third week of our lecture on the course titled Business Mathematics 2 with a course called ACC222. Our topic of discussion today is integration. When we say integration, simply means reverse of differential process. It means the differential calculus that you have done in your first week of this semester. It means that you have to revise it. That is why we talk. What is what we call integration. So it starts with the differential coefficient and construct the equation that if the differentiated will have been given raised to this differential coefficient. This is done by adding 1 to the index to get back to the original index and dividing the time by the numbers. So the main objective of this topic is to explain that integration is the reverse of differentiation. Differentiation is calculate the slope resulting from a given equation. Integration shows, among other things, the equation that will be given to raise to give a slope. Illustrate a second use of integration, that is how it can be used to find the area between 2 points under the curve. Integration can also help you to do that. It can introduce an idea, move on the explain, define, and then shows the possible use of what context. That is the idea of what differentiation. Process of differentiation and formula. The differentiation process is represented as you can see on the slide. So the formula of integration is if the equation of if d1 dx is given as n x raised power n, you have to revise it to the normal equation. It means that from the differentiation you have to revise back to from the differential you have to revise back to the normal equation. Looking at this example, integration is equals to sum of raised x power 1 dx is equals to n all over n plus 1 x raised power n plus 1. This is known as integral of x raised power n. This approach can be used to integrate any power of x except 1 all over x, which is x raised power minus 1. This is a special case and is beyond the scope of this syllabus. Example 1. Integration as the reverse of differentiation. Consider the equation 2y is equal to x raised power 2. For you to solve this problem, you have to differentiate it. Now, differentiate 2y is equal to x raised power 2 is equal to dy all over dx is equal to x raised power n minus 1, which is equal to dy all over this is equal to 2x is equal to 2x raised power 2 minus 1, which is equal to what? 2x. By integrating, remember 2x the same thing as 2x raised power 1. When you are integrating this differential value back, it means that you are saying n all over 1 all over n plus 1 x raised power n plus 1. It means that n all over 1 all over 1 plus 1 is times 2x raised power 1 plus 1. The answer is y is equal to 1 over 2 times 2x raised power 2, which is the same thing as y is equal to x raised power 2, taking you to your normal equations. x raised power 3. This is our second example. First, you have to differentiate this dy all over dx. So 3 is equal to 3x raised power 3 minus 1 is equal to 2x raised power 2. By integration, you have to add 1 to the power of 2 and multiply the time by 1 all over 1 plus power of x, which you can, as you can see it, the 1 all over 2 plus 1 times 3x raised power 2 plus 1, which is the same thing as 1 all over 3 times 3x raised power 3 is equal to 3x raised power 3. Constant of differentiation. Differentiation produces an expression which is the slope of a line. This shows how dependent variable change in response to the independent variable. An equation may be contain a constant. A constant will not be affect the slope of a line and does not appear in the differential expression. Thus, if an equation is differentiated with respect to s, any term in that expression that does not contain s disappear. This causes a problem for integrations. Example: consider the following differential equation. If y is equals to x raised power 2 plus 40. Solution: when you are differentiating this equation, you will end up having 2x raised power 2 minus 1 plus 0, and the 40 is a constant value, has to be disappear from the process. The answer is 2x raised power 1, which is the same thing as 2s. When we are integrating 2s, we do not know the times. If any have disappeared during the differentiation process, an unknown constant is added in order to arrive at a complete integral. This is also known as indefinite integral. If you can see from the formula, is x raised power n dx plus c is equals to y is equal to 2x raised power 1 plus dA plus d, which is our constant value, which is the same thing as 1 all over 1 plus 1 times 2x raised power 1 plus 1 plus c, which is the same thing as y is equal to 1 over 2 times 2x raised power 2 plus what c, which is the same thing as to y equal to 2x plus 2x raised x raised power 2 plus c. The above integral are all indefinite integral. Note that c could be negative number. Assigning a value to a constant under integration. Sometimes you can assign a value to a constant to under integration. The constant can be evaluated and the equation of the curve found when a phi of corresponding value of x and y is known. For example, construct the curve for the differential equation dy all over dx. From this question, they already differentiate the equation. You are in now differential curve. You have to revise this solution to the normal position. If y equal to 40 and s is equal to 3, solution dy all over the a is equal to 3x raised power 2. By integrating this differential value, you can see 1 all over 2 plus 1 times 3x raised power 2 plus 1. As you see it now, is 1 all over 2 plus 1 times 3x raised power 2 plus 1 plus c, which is our constant value, is equals to y all over 1 all over 3 times 3 raised power x raised power 3 plus c, and y is equal to x raised power 3 plus c. From the equation, we have a value where y is equals to 40, s is equal to 3. From we have to substitute the value of x and y from the equation. Y is equal to x raised power 3 plus c, which is we have 40 equal to 3 raised power 3 plus c, which is we have 40 is equal to 27 plus c. By collecting the latter, we have 40 minus 27, which our value of c is 13. Gradation a sum or difference of function. When we say a sum, or that is addition, and difference is a minus. When a functions contain a series of terms which have been added or subtracted, each term is integrated separately. When we have a terms that combine plus and minus different terms from a equation, you have to integrate it separately. From this equation, from this example, you can see, consider the dy all over dx is equals to 12x raised power 3 plus 6x raised power 2 minus 4x plus 3x raised power 1 over 2. By integration, you have to integrate x raised power n dx. Y is equal to integrated open bracket 12x raised power 3 plus 6x raised power 2 minus 4x plus 3x raised power 1 over 2 closing bracket dx. It means that dx is affecting all what is in the bracket. Integration can also affect all what is in the bracket. You have to separate them one after the other. The 12x raised power 2, when we are reversing to a normal equation, you can see 1 all over 3 plus 1 times 12x raised power 3 plus 1. When we are reversing 6x raised power 2, you can see 1 all over 2 plus 1 times 6x raised power 2 plus 1 minus 1 all over 1 plus 1 times 4x raised power 1 plus 1 plus 1 all over 2 plus 1 times 3s raised power 1 over 2 plus 1 to the n by expansion. At the end, you have a value you have a value this is the end of the differentiation, integration as a topic of our third week. Thank you for listening. I appreciate you. If you have any question, you can ask in terms of integration. In the answer of any question, I will give you, I will ask you a question. Failure to respond, I will give you minus 20 in your assessment. Are you ready? Are you ready? You are not ready. Can I give you? So let us postpone the assessment to next week when we are meeting for the fourth week lecture. Thank you for listening. I appreciate you. I appreciate you. As I always say, I will still remain Mr. Lima Alhaji Mohammed, a lecturer in the Department of Accounting, which is a co-lecturer taking Business Mathematics 2 with a course called ACC122. Thank you, thank you, thank you. Goodbye. See you next week for the fourth week lecture. Thank you.